Welcome to G-Fun Facts Online. Today, we are not looking at the stars as static points of light. We are looking at them as engines of destruction. We are traveling 25 light-years away to the constellation Pisces Austrinus to witness a scene of unimaginable violence. Imagine two massive celestial bodies, asteroids, or perhaps icy planetesimals the size of dwarf planets, slamming into one another at speeds exceeding 22,000 miles per hour. The resulting explosion pulverizes them instantly, creating an expanding cloud of fine dust that glows like a ghostly ember against the cold backdrop of space. For astronomers, this isn't a tragedy, it is a revelation. This week, we are diving deep into the Fomalhaut star system to discuss the confirmation of a massive collision event, dubbed Fomalhaut CS2. This new debris cloud joins the remnant of a previous collision observed 2 decades ago, offering us a front-row seat to a planetary demolition derby. We are going to explore the Eye of Sauron star, the mystery of the vanishing planet, and what these violent smash-ups tell us about the birth and death of worlds. To understand the magnitude of what we are witnessing, we must first understand the stage upon which this drama is unfolding. Fomalhaut is one of the brightest stars in our night sky, a blue-white Class A star roughly 440 million years old. Now, compared to our middle-aged sun, which is 4.6 billion years old, Fomalhaut is a teenager. It is energetic, luminous, and surrounded by the messy leftovers of its birth. For decades, Fomalhaut has fascinated astronomers because of its debris disk. First discovered by the IRAS satellite in the 1980s and resolved in stunning detail by the Hubble Space Telescope in 2004, this vast ring of cold dust spans some 14 billion miles, dwarfing our own solar system. The ring is sharp-edged and slightly offset from the star, giving the system the eerie appearance of a giant eye staring back at us across the cosmos, earning it the nickname, the Eye of Sauron. This ring is not just decoration, it is effectively a Kuiper belt on steroids. While our solar system's Kuiper belt, which is home to Pluto and Arrokoth, contains icy remnants of planet formation, Fomalhaut's belt is younger, denser, and far more volatile. It is a chaotic swarming ground for billions of comets and asteroids, all jostling for position under the gravitational influence of the star and its unseen planets. It is here, in this dusty ring of fire, that the demolition is taking place. To truly appreciate the discovery of this new collision, which we are calling CS2, we actually need to go back in time and revisit one of the most famous controversies in modern astronomy, the case of Fomalhaut B. In 2008, astronomers using the Hubble Space Telescope announced a historic breakthrough. They had spotted a tiny point of visible light moving along the inner edge of Fomalhaut's dust ring. It was hailed as the first exoplanet ever directly imaged in visible light. They named it Fomalhaut B. But almost immediately things didn't add up. The object was incredibly bright in visible light, but invisible in the infrared. A real planet with the mass of Jupiter should glow with heat from its formation, but Fomalhaut B was cold. Furthermore, as years passed, the planet didn't follow a stable elliptical orbit like a normal world. It appeared to be on an escape trajectory, drifting out of the system. Then came the vanishing act. By 2014, the object had begun to fade. By 2020, it had disappeared completely. Planets do not just vanish. The scientific consensus shifted dramatically. Fomalhaut B was never a planet. It was a dust cloud. We had been tricked. We hadn't taken a picture of a solid world. We had snapped a photo of the aftermath of a titanic collision. 2 icy asteroids, likely 125 miles wide, had smashed together shortly before Hubble looked that way in 2004. The planet was the resulting cloud of fine dust, expanding and dispersing into space until it became too thin to see. Fomalhaut B was reclassified from Planet to Collision Sequence 1, or CS1. It was a ghost, a temporary scar on the system. And now, history has repeated itself. According to new findings published in Science this week, astronomers monitoring the Fomalhaut system noticed a new point of light appearing in the debris ring, distinct from the location of the now-vanished Fomalhaut B. Dr. Paul Callis, a lead researcher on the project, noted that they were looking for the ghost of the first object, but they found a new phantom. This new object, designated Fomalhaut CS2, behaves almost exactly like its predecessor. It is a concentrated cloud of light that was not present in earlier archival images, and over the last few years of observation it has shown signs of expansion. You might be wondering, how do we know it is a collision and not a planet? The evidence lies in the light. First, there is the scattering effect. The object is bright in visible light because it consists of extremely fine dust particles. These particles act like a giant reflector for the central star's light. Second, there is the lack of heat. Like the first object, CS2 is faint in the thermal infrared. A massive planet would be glowing with internal heat. A dust cloud, however, has a vast surface area to reflect light but very little mass to generate heat. Finally, there is the transient nature. Planets are permanent fixtures. Clouds are transient. The fact that CS2 turned on recently suggests a singular event occurred, a hypervelocity impact. The estimated energy of this collision is staggering. Imagine two asteroids, each the size of a small moon, colliding head-on. The energy released would vaporize rock instantly, creating a cloud of microscopic silica and ice grains that expands at thousands of miles per hour. This cloud is what our telescopes are picking up. This discovery would have been impossible without the synergy between our two greatest space observatories, the Hubble Space Telescope and the James Webb Space Telescope, or JWST. Hubble remains the king of resolution in visible light. Its coronagraph, a device that blocks the blinding glare of the central star, allowed astronomers to see the faint reflected light of the dust ring. Hubble provided the baseline, the before pictures that proved CS2 wasn't always there. JWST brought a new dimension to the study. Its mid-infrared instrument looks at heat. By observing Fomalhaut in the infrared, JWST confirmed that there were no massive hot gas giants at the location of the collision. It helped rule out the planet theory. Furthermore, JWST has resolved the structure of the inner dust belts with unprecedented clarity, showing us the gap between the star and the ring, where terrestrial planets might be hiding. The combination of Hubble's timeline, spanning 30 years, and JWST's sensitivity has transformed exoplanetary science from taking snapshots to watching movies. We can now track changes in these systems on human timescales. But why should we care about rocks smashing together 25 light-years away? The answer is because Fomalhaut is a time machine. Our solar system is currently in a state of relative peace. The planets are in stable orbits, and major collisions are rare, with the extinction of the dinosaurs 66 million years ago being a notable exception. But it wasn't always this quiet. Approximately 4 billion years ago, our system underwent a period known as the Late Heavy Bombardment. During this era, the migration of the giant planets, Jupiter and Saturn, disrupted the orbits of asteroids and comets, sending them raining down into the inner solar system. Earth, the Moon, Mars, and Venus were pummeled. This violence was creative, as well as destructive. Many theories suggest that Earth's oceans were filled by icy comets and hydrated asteroids, impacting the surface during this time. Our own Moon is the result of a massive collision between Earth and a Mars-sized protoplanet named Theia earlier in our history. By watching Fomalhaut, we are seeing a similar bombardment phase happening in real time. The Fomalhaut system is currently organizing itself. Its gravity is shifting, its belts are being stirred up, and bodies are colliding. As Dr. Meredith McGregor, an astrophysicist specializing in debris disks, puts it, we are witnessing the construction of a planetary system. Every time we see a flash like CS2, we are seeing the building blocks of planets being ground down or built up. It is a messy, violent, and necessary part of making a world. Despite the incredible debris ring and the evidence of collisions, one mystery remains. Where are the actual planets? A ring this sharp and well-defined usually requires a shepherd planet, a massive world whose gravity keeps the dust in line, much like how shepherd moons keep Saturn's rings in place. For years, Fomalhaut B was thought to be that shepherd. Now that we know B was just a dust cloud, the shepherd is missing. However, the presence of these collisions hints at a bustling, unseen population. You cannot have collisions without things to collide. The Fomalhaut ring is likely teeming with planetesimals, objects 10 to 100 kilometers in size, dwarf planets similar to Pluto, and potentially super-Earths. The elusive shepherd planet may be a super-Earth or mini-Neptune that has so far evaded direct detection because it is cooler and smaller than the gas giants we usually photograph. The collisions act as tracer fire. Just as smoke reveals the invisible wind, the dust from these crashes reveals the invisible gravitational currents of the system. The sheer frequency of these crashes, seeing two massive ones in just 20 years, suggests the system is far more dynamic and crowded than we previously thought. The discovery of CS2 marks the beginning of a new era called time domain exoplanetary science. In the past, we thought of star systems as static paintings. We took a photo, and it stayed that way. Now we realize they are dynamic videos. Things change. Clouds expand, rings warp, flares erupt. Fomalhaut is not alone. Beta Pictoris, another young system 63 light-years away, recently showed a cat's tail of dust, likely from another massive asteroid collision detected by JWST. Vega, the star made famous in the movie Contact, also has a debris disk that shows signs of clumpiness, potentially indicating recent impacts. As we stare longer and harder at these nearby stars, we will likely see more flashes of destruction. We are realizing that the galaxy is a lively place. It is humbling to stand under the night sky, look toward the southern fish, and know that 25 light-years away, worlds are dying so that others might live. The planetary demolition in Fomalhaut is not just a spectacle, it is a laboratory. It challenges our models of how fast planets form, and how long the chaotic bombardment phase lasts. It reminds us that our own peaceful blue marble was forged in a similar fire, a survivor of a billion cosmic car crashes that eventually settled into the stable home we know today. As Hubble continues its watch and JWST peers deeper into the dust, we can expect more surprises from the Eye of Sauron. The demolition isn't over. In fact, we have only just started watching. This has been G Fun Facts Online, bringing you the universe one smash up at a time.